beneath us lies an abundance of resources that holds the key to a future with sustainable energy, advanced technologies, and unprecedented growth. Yet, the world is struggling to meet the demands of the energy transition. We need 500% more minerals to power its key elements, such as electric vehicles, infrastructure for solar and wind power, and batteries for grid-scale energy storage. To think about this in another way, we need as much copper in the next 15 years as we did in the last 120 years. On top of this, we need an estimated 41 new nickel mines, 30 new lithium mines, and 21 new cobalt mines. This shift toward a cleaner energy mix cannot happen unless we locate the minerals required more rapidly than ever before in human history. This is no easy feat. With current state-of-the-art technologies, 90% of the drills in the mining industry are in the wrong place, making exploration extremely inefficient. Even with vast financial capabilities, it takes at least 8 to 10 years to discover and mine a deposit. One key reason for this inefficiency can be attributed to low-resolution exploration. The standard exploration workflow involves collecting low-resolution geophysical data, often by hand, to identify drill targets. The challenge is that these datasets provide very limited information and are therefore not actionable. As a result, explorers are forced to use drills as an exploration tool. This is unimaginably expensive, slow, and detrimental to the environment. How do we then tap into the potential of our nations to elevate the quality of life for our people? At Atomionics, we are solving this challenge by mapping the layers of the subsurface to understand and effectively manage the abundance of resources under us. Gravio, our quantum sensor, acquires all the geological information there is and supercharges it with Oreo, our AI platform, to create a 3D image of the underground. We not only map out the layers, but also the details within each layer. Gravio can be deployed on drones for collection of continuous gravity data over large regions. The existence of subsurface features has a direct impact on the gravitational field. For example, an ore body that is denser than the host rock will show up as a gravity high, and a water reservoir will show up as a gravity low. Gravio's continuous gravity data acquisition ensures that all geological information is captured. This is done along multiple parallel lines to cover the area of interest. These lines are then gridded together to create a 2D gravity map of the region to identify anomalies. This map is processed to create 3D density inverted models. Density inversion involves mathematically pinpointing the source of the anomaly and visualizing density distribution in 3D space. With low-resolution datasets, there is uncertainty introduced into these 3D models. But Gravio's high-resolution data reduces ambiguity due to the additional data points being used as regularization. Density-inverted models typically require the subjective interpretation of experienced geologists, but we turn this art into science by having Oreo, our AI geologist, to interpret these models and characterize geological features of interest. The gravity data collected can be processed differently to identify different geological features, like ore bodies, oil and gas, or geothermal reservoirs. This means that you only need to collect gravity data once, and it can be reused to serve many purposes. Last year, we successfully completed the world's largest quantum gravimetry survey in the outbacks of Australia, covering over 200 square kilometers. Concurrently, we miniaturized another system and took it to the other side of the world in the US. These deployments allowed us to prove our system's capabilities in a variety of environments around the world. As we scale, Atomionics has forged partnerships with industry leaders across the globe, including DSO in Singapore, Bridgeport in Australia, and Rio Tinto in the US. Countries with abundant resources are seeking a competitive edge, and we are here to provide it. We are working with Australian governments and In-Q-Tel because, like us, they believe in the potential of using quantum technology to pinpoint resources in Australia and the US. Our end goal is to map the entire planet, and we are starting with countries and organizations who want to lead the energy transition. Energy diversification, energy independence, energy security. We can give it to you all.